Hey, folks, Johnny Vandeford here, Lorain County Community College, MEMS Microelectronics Manufacturing Program, and Merit Manufacturing Electronics and Rework Institute for Training. We recently got a firmware upgrade on our Panasonic NPM-W2 SMT Pick Place system. It's got a whole lot of nice features with them here, but we'll be reviewing that in our classes that we're currently running for our juniors and our seniors within our microelectronics manufacturing program. But one of the things I kind of wanted to do, we have a class coming in tomorrow and on Wednesday who will be using the SMT line for the first time. And one of the things that I want to kind of do with them is to introduce a potential, like a defect that is not always going to occur when I am, picking up and placing down parts, but something that I definitely want to kind of like show up as like, yeah, occasionally not every part gets picked up correctly because of various problems with this. And the typical thing I do on the first day is I take one of the 1206 resistors. Then let me tell you, the board that we make has 4 different types of 1206 resistors and a voltage regulator to turn 5 volts into 3.3 volts. Not horribly complex to really be able to do, but at the same time, it's a learning circuit board that we're teaching at our community college. And so what I'm going to do is I'm going to show you how to change the thickness of the part using the interface that we've got with this here. Move a little bit closer. Hello, screen. There we go here. All right. See the screen? Okay, here. So I'm going to change the thickness of my 1 mega ohm resistor. You can see here, if I go to my my PCB setup menu, I'm going to go to supply parts. I'm going to make sure that all the tape and reel feeders all have components into it. There we go. That's my resistor I want to do. I've got some 1206 resistors, a 1 ohm, 100 ohm, 75 kiloohms, and a 1 mega ohm resistor. And I want to change this part. I want to change the thickness of this part so that it inconsistently gets picked up. And what that means is I'm actually going to raise or lower the thickness down, raise the thickness up of this part as it's been programmed into here. What that means is if the part is this thick, the nozzle has been programmed to come down on top of the part and pick it up. But if I program that the nozzle is actually an inch taller than this, well, the nozzle is going to come down to where it's an inch taller, and maybe vacuum will suck the part up to it, but I'm kind of counting on that being inconsistent. That's been happening over the last 6 years, where we teach the students like, hey, something kind of went wrong here, so let's see if we can fix it. Now, they're not going to learn how to fix it on the very first week. What I'm going to do is introduce it so that they see it as an observable issue when they're manufacturing the board. I'm going to go to engineering board. That's the PCB with the paper that's with it down here. I've got, look at all this stuff. I love telling the students, see the 2 buttons up there? The one with the pen, that's where I change numeric quantifiable information. And the one with the yellow gradical up here, that's where I change the visual information, camera-based information for that. So we're going to go down to the feeders for this part. There's my circuit board here, 28-R, and I'm going to change the part's shape for this, right? So right now it's on the 1 mega ohm resistor, and these resistors are all about 0.55 in size, maybe some of them not even. This one's 0.65 in size for this one right here. But I'm going to take the 1 mega ohm resistor, and there's its length, there's its width, there's its thickness T. Now I'm going to increase this up to 0.8 millimeters tall. What that means is it's going to come down, not quite all the way, and every once in a while, like once every great while, it's going to, oh, I can't pull a resistor up. It's just not enough. And it's going to skip over the next one, put it through and say, I wasn't able to pick up a particular part with that one there. So we're doing this to introduce problem-solving techniques on the SMT line, which is an important thing to be able to have an SMT operator or engineer know how to do with that there. Very, very important for really any SMT line for them. So short video for that. There'll be more to come. Sorry, I've been away for a little bit with this here. We were doing a whole bunch of work with our program. There's been a lot going on, but I want to make sure that there's still a continuous stream of videos kind of coming your way, just little short tidbits for things every once in a while. So if you want to hear about something, want to hear more about something, leave a comment down in the comment below. And we will see you around next time at the Lorain County Community College MEMS and Microelectronics Manufacturing Program, as well as Merit Manufacturing Electronics and Rework Institute for training. We'll see you later, folks. Bye-bye.